How are you guys? My name is Vincent Smoko, and today we are going to be discussing the measures of central tendency. In specific, we are going to be looking at measures of central tendency or measures of location for ungrouped data. So the frequently discussed measures of central tendency are the mean, which is also known as the average, the median, and the mode. So these three are the mostly widely talked about measures of central tendency. A measure of central tendency is a way of finding the value or values in the middle of a data distribution, and hence the title measures of central tendency. So we are going to first look at the mean. So the mean is found by adding up all the values in the dataset and dividing by the number of the observation. So the population mean is usually denoted by mu. This sign is called mu. In statistics, it usually stands for the population mean. We will discuss more about populations and samples in another lesson. And the sample mean is given by x bar. So this sign is called summation. It means that all the values of x are being added up, and n here stands for the number of observations. So n in statistics, the small letter n usually denotes the sample size, and the big letter n usually denotes the population size. So let's look at an example. Example 1 is saying Florida police station in Mutare keeps a track record of the number of traffic accidents in their neighborhood. The number of traffic accidents in a week are given below. Find the mean. So here we first write our formula. Mean denoted by x bar is equals to summation x over n. So this is equals to 4 plus 5 plus 8 plus 5 plus 3 plus 2 plus 6 all over how many observations do we have? We have 1, 2, 3, 4, 5, 6, 7. So all divided by 7, and this gives us 33 over 7. And hence the mean here is equals to 4.714. So the average number of accidents per day is 4.7. So let's go on to look at another example. Example 2. Example 2 is saying find the mean for the following numbers. So we have 78, 66, 92, 25, 56, 95, 45, 63, 74, 61. So again, the mean x bar is equals to summation x over n. So this is equals to, if we add all the observations, 78 plus 66 plus 92 plus 25 plus 56 plus 95 plus 45 plus 63 plus 74 plus 61, we get 655. All divided by, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All over 10. So the mean here is 65.5. That's our mean. So that's how we find the mean for ungrouped data. The median is the central or middle score of observations that have been ordered by magnitude. The ordering can be either ascending or descending. If the number of the observations is odd, the median is given by the formula. So this is the formula for finding the median. So let's look at an example which is following. Which is example 3. The number of emergence cores classified as domestic disturbance cores in a large metropolitan location were sampled for 50 randomly selected 24-hour period with the following results. Find the median. So from definition, we learned that the median is the central score of observations that have been ordered by magnitude. So the first thing here is to order these observations by magnitude. So if we order these observations by magnitude, we will get 22, 25, 27, 29, 30, 34, 36, 37, 38, 40, 40, 45, 46, 47, and 58. So just to verify, here I know I have 15 observations. So on the values that I've ordered, I'm just going to check. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's okay. So the median is the central score. So the central score is the 80th observation. So 1, 2, 3, 4, 5, 6, 7, 8. So this is the central score. So if I check on the left hand side, I have 1, 2, 3, 4, 5, 6, 7 observations. And on the right hand side, I have 1, 2, 3, 4, 5, 6, 7 observations. So the median is equals to 37. So let's go on to look at another example. Example 4. Example 4 is saying 18 migrants to Zimbabwe were asked how many years to the nearest year they have lived in Zimbabwe, and the results are as follows. Find the median. Again, the first thing that we need to do here is to sort the observations by magnitude. So if I sort the observations by magnitude, I'll have 1, 2, 4, 5, 5, 5, 7, 7, 8, 10, 12, 15, 19, 20, 20, 23, 32, 43. Again, I'm going to check the observation that I have here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So my data is good. So here we have the number of observations in this case is an even number. So what do? We take the two middle points and we find the average. That will be our median. So the two middle numbers are the observation which is on the 9th observation and the 10th observation. So median is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is equals to 8 plus 10, because these are the two central observations. Then I divide this by 2. So the median is equals to 18 over 2, which is equals to 9. Again, if I check on the left hand side, I have 1, 2, 3, 4, 5, 6, 7, 8 observations. And if I check on the right hand side, I have 1, 2, 3, 4, 5, 6, 7, 8 observations again. So let's go on to discuss the mode. By definition, the mode is the most popular observation, or the observation with the highest frequency. So let's look at example number 5. If we check on example number 5, 5 is appearing 3 times. So 5 with 1, 2, 3. And it is unlike any other observations. We have 20, which is appearing 2 times. So the mode is equals to 5, because it is the most popular observation, or it is the observation with the highest frequency. Okay. So on this chapter, this is a typical exam question. The typical exam question that I have provided reads: the maximum daily temperature in degrees Celsius recorded for the month of June. The maximum daily temperatures in degrees Celsius was recorded for the month of June with the following results. Find the mean, median, mode. So these first 3 are the measures of central tendency. Again, one will be required to find the range, interquartile range, variance, and standard deviation. And the latter These ones are the measures of variability. So these are central, location, and these one are measures of variability. We will look at the measures of variability after discussing the measures of central tendency for grouped data. So let's just solve this typical exam question. So first we are required to find the mean. So mean, which is denoted by x bar, is found by summing up all the observations and dividing by the number of observations. So here we get, summing up all the observations, we get 546, all divided by 30. So the average daily temperature is 18.2 degrees Celsius. Then the median, to find the median, we arrange the data by order of magnitude. So that will be 12, 12, 13, 14, 15, 16, 16, 16, 17, 17, 17, 18, 19, 19, 19, 19, 19, 19, 19, 19, 20, 20, 20, 20, 20, 22, 22, 22, 22, and 23. So the median, I want the 5th and the 16th, 15th and 16th observation. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So median is equals to 19 plus 19 all over 2, which is equals to 19 degrees Celsius. So here the value of the median is 19 degrees Celsius. Also, the mode is equals to 19 degrees Celsius. Why? Because 19 is the most popular observation as it is appearing 8 times. I'm not supposed to calculate the measures of variability as of yet because we haven't covered them, but I'm going to just make a quick run through. So we are again also asked to calculate the range. We will look at this. Range is found by subtracting the maximum value, subtracting the minimum value from the maximum from the minimum value from the maximum value. So it is max over mean. So the maximum temperature is 23 and the minimum temperature is 12. So the range is equals to 11. And the interquartile range is found by Q3 minus Q1. I'll explain what is Q1 and Q3 in this lesson. So Q3 is equals to 3n plus 1 over 4t observation, which is equals to 3 times 30 plus 1 over 4 the observation. So this is our, if we round off, this is our 23rd observation. And our Q1 is equals to n plus 1 over 4 the observation, which is equals to 31 over 4 the observation, which is equals to, if we round off, that's the 8th observation. And our 8th observation is equals to 16. Our 23rd observation is equals to 20. So the interquartile range is equals to 20 minus 16, which is equals to 4. Let me erase this to create some space. So that we calculate the variance and the standard deviation. Variance is denoted by a squared and is found by summation of x squared minus n x bar squared all over n minus 1. So the summation of x squared, this gives us 10,190 minus our n is 30 and our mean is 18.2 all over 30 minus 1. So if we solve this, we find 8.7172. The standard deviation is denoted by S and it is found by finding the square root of variance, which is 8.7172. So the standard deviation is equals to 2.9525. So we have come to the end of today's lesson. So these are other services that I provide. So if you know someone or if you need these services, please feel free to get in touch with me on the provided contact details. And if you have not subscribed to my channel, please subscribe. Also like and comment on these videos. So in our next lesson, we are going to be discussing the measures of central tendons for ungrouped, for grouped data. Thank you.